Top 25 Infrastructure Engineer Interview Questions and Answers. Infrastructure engineers play a critical role in designing, managing, and maintaining reliable technology environments. They work with servers, networks, cloud platforms, security systems, automation tools, and monitoring solutions to ensure business applications run smoothly. Preparing for an infrastructure engineer interview requires knowledge of system administration, cloud computing, DevOps practices, troubleshooting, and infrastructure management. This guide provides 25 commonly asked infrastructure engineer interview questions with detailed answers to help candidates understand key concepts and confidently prepare for technical discussions. 1. What is the role of an infrastructure engineer? An infrastructure engineer is responsible for building, maintaining, and improving an organization's IT infrastructure. Their duties include managing servers, networks, storage systems, cloud resources, security configurations, and automation processes. They monitor system performance, troubleshoot issues, implement backups, and ensure high availability. Infrastructure engineers also collaborate with development and security teams to improve reliability. They need strong knowledge of operating systems, networking, virtualization, scripting, and cloud technologies to maintain efficient and scalable environments. 2. What are the main responsibilities of an infrastructure engineer? The main responsibilities of an infrastructure engineer include designing infrastructure solutions, managing servers, maintaining networks, monitoring system health, and resolving technical problems. They handle deployments, upgrades, security improvements, disaster recovery planning, and automation tasks. Infrastructure engineers also manage cloud resources, configure hardware and software, and ensure systems meet performance requirements. Their goal is to create stable, secure, and scalable environments that support business operations while minimizing downtime and operational risks. 3. Explain the difference between physical servers and virtual servers. Physical servers are dedicated hardware machines where applications run directly on the operating system installed on the server. Virtual servers use virtualization technology to create multiple independent environments on a single physical machine. Virtualization improves resource utilization, flexibility, and scalability. Tools like VMware and Hyper-V allow organizations to create virtual machines. Infrastructure engineers manage both environments depending on business needs, performance requirements, budget limitations, and availability expectations. 4. What is virtualization and why is it important? Virtualization is a technology that allows multiple virtual systems to run on a single physical machine. It separates hardware resources from operating systems and applications. Virtualization improves efficiency, reduces hardware costs, simplifies management, and enables faster deployment. Infrastructure engineers use virtualization platforms to create test environments, production systems, and disaster recovery solutions. It also supports cloud computing because cloud providers rely heavily on virtualization technologies to deliver flexible resources. 5. Explain the importance of monitoring infrastructure. Infrastructure monitoring helps organizations identify performance issues, failures, and security problems before they impact users. Engineers use monitoring tools to track CPU usage, memory consumption, network traffic, application performance, and system availability. Effective monitoring enables proactive troubleshooting and reduces downtime. Tools such as Nagios, Zabbix, and Prometheus help collect and analyze system metrics. Infrastructure engineers use monitoring data to improve reliability, optimize resources, and maintain stable IT environments. 6. What is cloud computing and how does it help infrastructure engineers? Cloud computing provides on-demand access to computing resources such as servers, storage, databases, and networking services through internet-based platforms. Infrastructure engineers use cloud services to deploy applications quickly, scale resources, and reduce hardware management responsibilities. Platforms like AWS, Microsoft Azure, and Google Cloud provide flexible infrastructure solutions. Cloud computing allows engineers to automate deployments, improve disaster recovery, and create highly available systems without investing heavily in physical infrastructure. 7. What is Infrastructure as Code (IAC)? Infrastructure as Code is a method of managing infrastructure through automated configuration files instead of manual processes. Engineers use tools like Terraform, Ansible, and CloudFormation to create and manage servers, networks, and cloud resources. IAC improves consistency, reduces human errors, and allows infrastructure changes to be tracked through version control. It helps teams quickly reproduce environments and supports DevOps practices by making infrastructure deployment faster and more reliable. 8. Explain the difference between Linux and Windows servers. Linux and Windows servers are operating systems used to host applications and services. Linux servers are widely used for web hosting, cloud environments, and automation because they are flexible and support powerful command line tools. Windows servers are commonly used in organizations relying on Microsoft technologies such as Active Directory and .NET applications. Infrastructure engineers choose between them based on application requirements, security needs, performance expectations, and organizational standards. 9. What is Active Directory? Active Directory is a Microsoft directory service used to manage users, computers, permissions, and resources within a network environment. It provides centralized authentication and authorization management. Infrastructure engineers use Active Directory to create user accounts, apply security policies, manage groups, and control access to systems. It includes important services such as domain services, group policy, and authentication mechanisms. Active Directory helps organizations maintain secure and organized Windows-based environments. 10. What is DNS and why is it important? DNS, or Domain Name System, translates human-readable domain names into IP addresses that computers use for communication. Without DNS, users would need to remember numerical IP addresses instead of website names. Infrastructure engineers manage DNS records, troubleshoot resolution issues, and configure DNS servers. DNS plays a critical role in network availability because incorrect configurations can prevent applications and services from being accessed properly. 11. Explain DHCP and its purpose. DHCP, or Dynamic Host Configuration Protocol, automatically assigns IP addresses and network settings to devices connected to a network. It reduces manual configuration and prevents IP conflicts. Infrastructure engineers configure DHCP servers, manage address ranges, and troubleshoot connectivity issues. DHCP provides essential information such as subnet masks, gateways, and DNS servers. It simplifies network administration, especially in large environments with hundreds or thousands of connected devices. 12. What is a firewall? A firewall is a security system that controls incoming and outgoing network traffic based on predefined rules. It protects infrastructure by blocking unauthorized access and allowing legitimate communication. Infrastructure engineers configure firewalls to secure servers, applications, and networks. Firewalls can be hardware-based or software-based and are commonly used with cloud environments. Proper firewall management reduces security risks while maintaining necessary connectivity between systems and users. 13. Explain load balancing. Load balancing distributes network or application traffic across multiple servers to improve performance and availability. Instead of sending all requests to one server, a load balancer shares the workload among multiple systems. Infrastructure engineers use load balancing to prevent overload, improve response times, and support high availability. Technologies such as application load balancers and network load balancers are commonly used in enterprise and cloud environments. 14. What is a backup strategy? A backup strategy defines how an organization protects and restores important data during failures, accidents, or disasters. Infrastructure engineers design backup plans that include backup frequency, storage locations, retention periods, and recovery procedures. Common backup types include full, incremental, and differential backups. A strong strategy ensures business continuity and minimizes data loss. Engineers regularly test backups to confirm that recovery processes work effectively when needed. 15. Explain disaster recovery. Disaster recovery is the process of restoring systems, applications, and data after major failures such as hardware problems, cyber attacks, or natural disasters. Infrastructure engineers create recovery plans that define backup systems, recovery timelines, and emergency procedures. Important concepts include recovery point objective and recovery time objective. Effective disaster recovery planning ensures organizations can continue operations and reduce the impact of unexpected infrastructure failures. 16. What is RAID? RAID, or Redundant Array of Independent Disks, combines multiple storage drives to improve performance, reliability, or both. Different RAID levels provide different benefits. RAID 1 mirrors data between drives for redundancy, while RAID 5 distributes data and parity across multiple disks. Infrastructure engineers use RAID configurations to protect data and improve storage performance. RAID does not replace backups but provides additional protection against hardware failures. 17. What is containerization? Containerization is a technology that packages applications and their dependencies into lightweight, portable containers. Containers allow applications to run consistently across different environments. Infrastructure engineers use tools like Docker and Kubernetes to deploy and manage containers. Containerization improves scalability, deployment speed, and resource efficiency. It is widely used in modern DevOps environments because it simplifies application delivery and infrastructure management. 18. Explain Kubernetes. Kubernetes is an open-source platform used for automating the deployment, scaling, and management of containerized applications. Infrastructure engineers use Kubernetes to manage clusters, schedule workloads, monitor application health, and maintain availability. It provides features such as automatic scaling, self-healing, and service discovery. Kubernetes helps organizations operate large container environments efficiently and supports modern cloud-native application architectures. 19. What is CI/CD? CI/CD stands for Continuous Integration and Continuous Delivery or Deployment. It is a software development practice that automates building, testing, and releasing applications. Infrastructure engineers support CI/CD pipelines by managing deployment environments, automation tools, and infrastructure configurations. CI/CD improves software delivery speed, reduces errors, and enables reliable releases. Popular tools include Jenkins, GitLab CI, and GitHub Actions. 20. How do you troubleshoot a server issue? Troubleshooting a server issue requires a systematic approach. Infrastructure engineers first identify symptoms, check monitoring alerts, review logs, and analyze resource usage. They verify network connectivity, services, configurations, and recent changes. Engineers isolate the problem, apply corrective actions, and document the solution. Effective troubleshooting requires technical knowledge, attention to detail, and the ability to analyze problems without causing additional system impact. 21. What scripting languages are useful for infrastructure engineers? Infrastructure engineers commonly use scripting languages such as Python, Bash, and PowerShell to automate repetitive tasks. Scripts help manage servers, perform backups, monitor systems, and deploy applications. Automation improves efficiency and reduces manual errors. Python is widely used because of its flexibility and large library ecosystem. Bash is common in Linux environments, while PowerShell is important for Windows administration and Microsoft-based infrastructures. 22. Explain network troubleshooting steps. Network troubleshooting involves checking connectivity, configurations, and performance issues. Engineers start by identifying the problem, testing connections, verifying IP settings, checking DNS resolution, and analyzing network traffic. Common tools include ping, traceroute, netstat, and packet analyzers. Engineers review firewall rules, switch configurations, and routing settings. A structured troubleshooting process helps identify the root cause quickly and prevents repeated network problems. 23. What is high availability? High availability refers to designing systems that remain operational with minimal downtime. Infrastructure engineers achieve high availability through redundancy, clustering, load balancing, and failover solutions. Critical services are deployed across multiple servers or locations to reduce failure risks. High availability is important for businesses that require continuous access to applications and services. Proper planning ensures systems can handle failures without significant disruption. 24. Explain DevOps and its relationship with infrastructure engineering. DevOps is a culture and practice that combines software development and IT operations to improve collaboration and automation. Infrastructure engineers support DevOps by creating automated environments, managing cloud resources, implementing infrastructure as code, and maintaining deployment pipelines. DevOps helps teams deliver applications faster and more reliably. Infrastructure engineers play a key role in creating scalable platforms that support modern software development processes. 25. How do you ensure infrastructure security? Infrastructure security involves protecting systems, networks, and data from unauthorized access and attacks. Engineers implement security measures such as access controls, patch management, encryption, firewalls, monitoring, and vulnerability assessments. They follow security best practices and regularly update systems to reduce risks. Security-focused infrastructure management ensures reliable operations while protecting sensitive business information from threats and potential breaches. Infrastructure engineer interviews require a strong understanding of systems, networking, cloud platforms, automation, security, and troubleshooting techniques. The questions covered in this guide represent common topics discussed during technical interviews for infrastructure roles. Candidates should practice explaining concepts clearly and demonstrate practical experience with real-world scenarios. Building hands-on skills with servers, cloud services, scripting, monitoring tools, and automation platforms will improve confidence and increase the chances of success in infrastructure engineering interviews.